Example number 4. So let's rewrite this one as what? Let's go ahead and move these variables, this variable x that's located in the denominator into the numerator position. So that would give us what? 6x to the negative 3, and then plus 6x to the negative 1. All right, let's go ahead and integrate this thing. So what do we get? We get 6x to the, we have a negative 3 initially, so we're going to add 1 to it, giving us a negative 2. Then we're going to divide by that new exponent. In the second term, we have 6x to the negative 1. This is a special case. The integral of x to the negative 1 is the natural logarithm of the absolute value of x. So that's what we get. We're looking at this over the closed interval from 1 to 5. There's your upper limit of integration. There's your lower limit of integration. Okay? At this point, we plug in those two values. So let's go ahead and reduce this as well. All right, so 6 divided by negative 2, that's negative 3. So here's what we get. Negative 3, and then 5 to the negative 2, plus 6 times the natural logarithm of 5. It's the absolute value of 5, but it's positive here, so we're good, keeping it as positive 5. So this is going to be the value of our upper limit, and then we have to subtract what we're going to get here for the value of our lower limit. So this is going to be negative 3 times the quantity of 1 to the negative 2 plus 6 times the natural logarithm of 1. All right, let's see what we get here. So this is going to be what? This is going to be negative 3 over 25 plus 6 ln 5 minus, well, this part right here is just exponents first. So 1 to any exponent is 1. 1 times negative 3 is negative 3. So we have this initially. And then this, what's the natural logarithm of 1? Good, it's 0. So 0 times 6 is 0, so that just gives us nothing. All right, so our final answer here is going to be what? In exact value form, your final answer is going to be whatever negative 3 over 25 plus 3 is equal to. Let's do that first. So negative 3 over 25 plus 3 is 72 over 25. And then bring this down. This is the exact value, folks, of your answer, of the value of this definite integral. Now, if you were asked to approximate it, then you could do so. Plug this in your calculator, and you get approximately 12.54. But understand, again, like I said in the previous example, leave it in exact value form unless the directions state otherwise. All right, example number 5. In this case, we have the quantity of a binomial being raised to the second power. So the first thing we're going to do is just an algebraic move, and that is we're going to square this quantity. So x squared minus 1 squared is the same as this trinomial. And so after we've successfully multiplied this binomial by itself to come up with this new expression, oops, there should be a square there. Geez. Now we're ready to come up with the definite integral. So here we go. First of all, the integral of this term would be x to the 5th over 5. Second term would be minus 2x cubed over 3. And the integral of a constant is just going to be the constant times x. So in this case, just 1x. And again, because we're looking at definite integrals, the upper limit of integration goes here, and the lower limit of integration goes down there. At this time, we're ready to rock and roll by using substitution. So here we go. The upper limit goes in first. And by that I mean the value 1 goes into every x in our integral. I'm using parentheses every single time to denote that substitution. So this is really f of a, or excuse me, this is really f of b, which is f of 1. And then we're going to subtract what? Well, this. Everywhere now you see an x, you're going to replace it with a negative 1. And so this is really f of a, which is f of negative 1. All right, so what do we get? Well, we get what? 1/5 minus 2/3 plus 1 minus negative 1/5 plus 2/3 and then minus 1. And so we get what? We get 1/5 minus 2/3 plus 1. That's going to equal 8/15. Use your calculator to check that. Minus negative 1/5 plus 2/3 minus 1, I believe, is negative 8/15. So a negative times a negative we know is a positive. So the final result is 8/15 plus 8/15, which is 16/15. It's the value of this definite integral. Example number 6. Now we're looking at the definite integral of e to the x with respect to x over the closed interval from 1 to 3. So here's what we get. As you should remember, I hope, from section 11.1, this is a special case. The integral of e to the x is just e to the x. Now all we have to do is evaluate this thing based upon this lower limit and upper limit of integration. So that would give us what? E cubed minus e to the first. This is your actual result. You cannot simplify this any further. This is exact. With that being said, if the directions state to round this to something, then you can get out your calculator, turn it on, and you could do what? You could do e cubed, not like that, jeez, e cubed minus e to the first, and that gives us 17, we'll go out 3 decimal places, 17 and 367 thousandths approximately. This is approximate.